All right, so today we're going to be working off of page 21. We're going to be talking about triangle proportionality theorem. Okay, it's a theorem dealing with parallel lines. So first we need to remember the fact that parallel lines, like we see here, those big arrows, mean that the lines are parallel. Now this goes back to our old units from last semester again. When we have parallel lines and a transversal, we have alternate exterior angles that are congruent. We have vertical angles that are congruent. We'll have alternate interior angles that are congruent. And then we have corresponding angles that are congruent. So we have all these vocab words that come to mind when we see those parallel lines. So what's going to happen is we're going to tie that in with triangles. So it's nice, new, different way of looking at it. All that happens on these ones now is the parts, because that's why it's proportionality theorem. The parts of the triangles now are proportional to each other. And just as before, we were able to write out a bunch of different proportions, the way you write them with what's on the numerator and denominator. You can write them a bunch of different ways still, as long as the sides, vertical and horizontal, still relate. So this triangle proportionality theorem is the fact that AB, so line segment AB here, over AE, that chunk there, would be proportional to BC over ED. So again, if you wanted to, you can write that out another way. You can say AE over AB would be proportional to ED over BC. Okay, and you can keep going from there. But the point is, the fact that when we have these parallel lines is that it cuts that one triangle proportionally so that the two sides across from each other are proportional to the two other sides. And again, a lot of different ways to write that out. One big thing we got to notice, this works with the chunks of the triangle. It will not work with these side pieces, okay? So we got to be aware of that. Like the bottom of the triangles, it does not work the same for them. It has to be the chunks, okay? So if this is true, the converse of the triangle proportionality theorem is the fact that if this is true, so if these chunks are proportional, then the lines are parallel. So we can say AC is parallel to AD. In the top part, we need to know first that the lines are parallel. So the converse is proving lines parallel. The original is proving the chunks proportional. Okay, and if I'm right, I think this triangle might have cut off in your notes a little bit. So you might want to take a note here and redraw this out real quick. That is super important for the problem. Step 1 of this problem, read it as always. It says in triangle PQR, perfect, there's triangle PQR, ST is parallel to RQ. And we can see that again because they showed us those arrows. So now it's telling us some important information. PT is 7.5, TQ is 3, SR is 2.5, and we want to find PS. So again, just think about how these relate. I know X relates to 7.5, it sits right across from it. 2.5 also relates to 3, sits right across from it. And X and 2.5 are on the same side, and 7.5 and 3 are also on the same side. So we're going to want to set up those proportions, cross multiply, or whatever you want to use to get X alone. So I'm going to write this out. I'm going to say it's going to go X over 2.5 same side, equals 7.5 over 3. So I did write that one out maybe a little bit differently than the top. I could have also said x over 7.5 equals 2.5 over 3. If you notice, no matter what I use, I will still be multiplying 2.5 and 7.5 and dividing by 3. So go with whatever route you like best. So here I'm going to put 2.5 times by 2.5. And we're going to solve for x. Easy peasy, just calculator work for us. So after we punch this all in the calculator, 7.5 times 2.5 divided by 3, we should get the answer that x is 6.25, which in this problem it asks to find PS. We wrote x there to represent PX when we filled that in. So our answer should be 6.25, and we can even, since we double check that, we can say that is PS. All right, so the next little definition we need to know is the mid segments of a triangle. So a mid segment of a triangle is a line that connects at the midpoints of the triangle. So if D is a midpoint, that means we know HD is the same as DG. And if E is a midpoint, we know that HE is the same as EJ. So whenever we have a mid-segment, okay, the mid-segment will connect the midpoints. Oops, almost there. It'll connect the midpoints. It also will be parallel to, so it'll be parallel to the opposite side of the triangle. So if you notice here, it shows that DE is a mid-segment, and that will be parallel to GJ. And then finally, it is half the size of the side that it's parallel to. So what that means is DE is half the size of GJ. So make sure you have those down. That's a big part of the mid-segment theorem. Obviously on this one we have several different ones. We can see EF is going to be parallel to HG. Therefore, EF is half the size of HG. Then we'll also, well, that's also given. This is a midpoint, so no, this is the same. So we see those are midpoints now. And then, same thing, DF over here would be parallel to HJ as well as half the size, just the way it works out every single time when we're given those mid segments of a triangle. So same idea over here, this mid-segment theorem is going to go off the same thing. Okay, the fact that if K and L were both midpoints of this triangle, then we know KL is parallel to MN. And we know KL is half the size of MN. We can also say that MN is double the size of KL. Whatever makes you happy there. So here's a little bit more complex problem to practice. We notice that we're seeing that things are congruent. So I can see D's are congruent. I'll remark them since it's a little blurry. But if you notice, obviously we see we got those chunks that are the same. So D has to be a midpoint. E is a midpoint. And F is also a midpoint. It's just midpoints of those specific lines. So now we want to find the each measure. So these ones are lengths. This is going to be degrees. So if we look here, I want to find DE first. DE relates to the side that it's parallel to. So DE here is parallel to AC. Now, because again, DE is the mid segment, how much of AC equals to DE? Well, we know that DE is half the size of AC. So we're going to take 15, because that's AC, and multiply it by half. So DE is going to be 7.5. Easy enough. Let's look at DB. Here's DB. All right, well, we know all of AB relates to FE because they are parallel, and that's a mid-segment. So FE is half the size of this entire thing. Well, if it's half the size of the entire thing, don't we agree that then it would be the same size as what we're looking for, DB? So then now here we know DB is going to be 9.2. And our last one, now we're digging around for an angle. So we're looking for angle FED. Here we are, angle FED. So we're going to start looking around and using our other angles here. So they really only give you this angle. So we're going to want to work off of that. What can we use off of that angle to figure out the angle of FED? All right, so for that degrees, we know this is 82. Therefore, the linear pair with it should be 98. So now we got to start manipulating everything to the fact that we remember those parallel lines and transversals are congruent. So I'm going to erase some things we have going on here so we can see a little bit clearer. All right, so again, we know these are parallel. I also know this is going to be 98 degrees. Now, if they're parallel and have the same transversal going through them, we know those angles relate. So we have this is 82 due to corresponding angles. This should also be 82. Okay, so helping us out there a little bit. Now, I kind of used all I could with that set of parallel lines. But we also know that these set of parallel lines will also exist as well. So now we can tie those in. So if this is 98 over here, same side interior angles tell me that they need to add up to make 180, or you have alternate interior angles there off that transversal as well. Okay, and then we can also see that's 82. This would have to be 98. Get rid of the thick lines there. So we're making our way, and oh, I already went too far. Bam. I could see right there that that angle is going to be 82 degrees. So when we're moving on to the next page, now we're talking about, you notice there's no triangles even in here. We're just talking about proportional parts of parallel lines. So very similar to that last one with those parallel lines, we know the parts of this are going to be similar. So it's going to be AB over BC is proportional to EF over FG. Again, a lot of different ways to write that out. And finally, because of that, if you have congruent parts here, For example, if AB was the same as